Okay, you had a pretty clever idea to let u equal 1 plus x. That way it gets less complicated, so I'm going to do that as well. So we have x over, well, I mean, we're going to change that back. We're going to use this again just to get it back, but just to make it a little bit more simple, what you did was nice. So we have the square root of u, because that's the same thing as the square root of 1 plus x. And then we'll have 2 times the square root of u. Alright. Now, it says to write as a single quotient, I think. Was that what you were saying? Let me see. Instructions were write each expression as a single quotient. Yeah, so we get a common denominator. That's all that means. Here we have a denominator of 1. So it would be x plus 2 whatever. And then this would be over u. However, I want to get a common denominator here, so I multiply it by a fancy version of 1, which is the square root of u over the square root of u. That's because of that square root of u. So then I'll have that part just changed to a regular u. So let me get rid of this. This will be a regular u. And then square root of u on the bottom. Now I've gotten common denominators. And then I can have x plus 2u divided by just that denominator written once, because they're common denominators. And then I'll substitute my u back in. So x plus 2 times 1 plus x. Right? And then 1 plus x. We'll just change it back. 1/2. Distribute the 2. X plus 2. Right now it's already a single quotient, but I'm just going to simplify it even more. So I have 2 plus 3x. I think I already, so this would be the single quotient. I think I already have number 63 up there. It's kind of silly still. You can use a u substitution. That might make it a lot easier to deal with. I didn't use one, and it was like kind of complicated. So there you go. Single quotient, meaning single fraction.